On to topic 3 of chapter 4. We're skipping section 2. This is systems of linear equations and problem solving. Now, in many cases, we're going to use two variables to set these problems up. So with this in mind, we should pause, have a chance to read it. We've gone over already the lecture portion of this and know that there are a number of steps needed to solve word problems. Going back to chapter 2, read it carefully, pick out a variable. In this case, we're going to try to pick out two variables and then make an equation out of it, or two equations, solve them, and then check. So let's take a look at this one. One number is 5 less than a second number. So we could say x is one number, is, we translate to equal signs, 5 less than a second number. Well, the second number will be y, and it's going to be 5 less. So one number is 5 less than a second number. Well, that's pretty straightforward. Now, twice the second number, we're saying y is the second number, so twice y is 2 less than 5 times the first number. Well, 5 times the first number, which we said is x, and it's 2 less than that. So again, I had done these before and have them pretty much written up. And, the first time I read them, I had to think, what variables will I use? What equations will generate from this? And now we're going to solve them, and you might say, well, what technique would we use? Well, if you said substitution, that would be a good technique. So we know then that x is this. So we're going to put this where that x is and rewrite the equation. So we get 2y equals 5. Now we're substituting this for our x value, y minus 5 minus 2. So we get 2y equals 5y minus 25 minus 2. We're going to group like terms, so we get 2y equals 5y, and this is minus 27. Now I'm running out of room here, so I'll put it over here. Let's transpose the 2y to this side, so we get on this side 3y now. Transposing the 2y to this side, I'm going to transpose the negative 27 to the other side. That'll give us a positive 27. Divide each side by 3, and we get that y equals 9. So we have one number. Well, if y is 9, we can put that 9 right here in this equation. X equals y, we say, is 9, minus 5. X equals 4. So there are two numbers. And if you go through this, these values satisfy this problem, this word problem, this application that we're working on. So in example B, And again, I didn't choose these problems. I would have chosen some other ones, but we'll do some others too. We have two trucks that leave a city and head in the same direction. So these are my two trucks heading in the same direction here. They're leaving, and they start off equal, and then one is faster, one is slower. Now the time is 7 hours, and after 7 hours the faster truck is this many miles ahead of the slower truck. So the slower truck is this many miles, 301, and we have to, in a sense, add this distance here that the faster truck is, which is 56, and the faster truck then is just going to be 357 if we add this and this. And the time for all of this is 7 hours. Well, we could use the formula distance equals rate times time, and that's what we're trying to find out. We're trying to find the rate of speed for both trucks. So for this one here, we'd use distance equals rate times time. So the distance here is 301. We don't know the rate, but we know the time. And for this other one, we know their distance is 357. We don't know its rate, but we know that that time is also 7 hours. So if we just divide both sides by 7 here, that will give us the rates. So 7 into 301 is 43, and 7 into 357 is 51. So I didn't really need two variables here. What I did need is an understanding of the problem, a diagram that I've made to help interpret it, and I end up with this. Now in this type of problem where they're using function, they're saying the cost function is given by this symbol. C is for cost, and revenue function is given by this symbol, where R is for revenue. Now a little background on this is that when we are making something and want to prepare it for sale, there are certain fixed costs that you might have for equipment and general things that you will need. But then as you produce each item, which we will call X, this will be the number of items we're going to produce, there are some specific cost of materials just for that. So this is the amount it takes to produce the materials for this item you're producing, and this is the general fixed cost. Whether you produce items or not, this is what you have to pay for machinery and other things. So when you look at the cost function, it's set up in this pattern. They're saying you have these fixed costs of $1,100, let's say, and materials cost to produce this one item is $95. And that applies here as well. that here your fixed cost to produce this is $1,400, where to make a particular item it costs that much in materials just for that little item there. So this is the general cost function. Now for revenue, you're going to sell a certain number of items, and the items that you sell will have a price. This is the sales price per item. So every item you sell, you bring in this much revenue. So here we see the item will sell for $105, and here you see the item is going to sell for 1.3. Remember, X is the number of items that you're making. So you're wondering, when will you break even? Now if we look at this in a graph, this equation where you start at 0 and shoot up is your revenue. Now notice the 1100 and the 1400 are in the position of B in your slope-intercept formula. So this is going to be somewhere up here on your graph, and it will shoot up like so. So somewhere in there these lines are going to intersect, and that will be your break-even point, where if you sell more items, then you will have a profit in this upper region here. But if you're down in here somewhere, you haven't covered your original cost. So how do we solve this type of, these types of equations? Well, remember, we said we could substitute a y for the function symbol. So y equals this and y equals that. So we could set this up as y equals y. So it would be 95x plus 1100, I should say, equals 105x. So now to solve for x, we're going to subtract 95 from both sides, and this gives us 10x equals 1100. We're now going to divide both sides by 10, and we get x equals 110. So if we sell 110 units, we're going to break even. If we sell 111, we make a profit. And the same thing applies here. We can substitute a y for each of these, and then we have the equation y equals y. So this will be 0.3x plus 1400 equals 1.3x. Subtract 0.3x from both sides, and this just gives you 1x here, and that's 1400. So this case worked out very easily. We would have to sell 1400 units to break even. So on your paper, you will write the cost function after reading this, and the revenue function after reading this, and see what you can come up with, because here they're not giving you these functions. Well, in this case, the company purchased $1,000 worth of new equipment to make gift boxes to sell. So here we're going to put $1,000. That's your fixed cost. Now the cost of producing a package of gift boxes is 50 cents. So here we're going to put 50 cents. So this is what it costs to make each item, and these were the fixed cost. Now what we have to find is the selling price, which will give us our revenue. And we see that here as $3. Again, they're looking for the break-even point. Well, we said we could put a y there and a y there, and y equals y, so it's just 0.50x plus 1,000 equals $3x. So we subtract 0.50x from both sides, and that gives us 250x on this side. We divide both sides by 250, and we get x equals 400. So we would have to sell 400 units to break even. Now I've added some worksheets to our booklet to give you a little more practice in reading word problems and then setting them up into their equations. This is from another book. Instead of 4.3, you see it's 4.5 in this book, but that's fine. We're not doing 4.5 in our math class, just using this as more examples. So with that in mind, we'll spend a little time going over these and see what you can come up with. And I think in other years what I've done is I've given various groups assignments to do these, and we'll fill them in as we go along. Now as we look at number 1, this was very similar to what we already had. One number, this is one number, is 5 more than another number. So y plus 5. One number is 5 more than another number. The sum of the numbers is 19. Well, that would be x plus y equals 19. Number 2, 4 times one number, well, I've given you a hint, 4 times one number is 11 more than a second number. Well, the second number would be y plus 11. And their sum is 14. So x plus y equals 14. The difference of two numbers is 8. Well, I've put the negative in there, so one number is x, the other number is y. I'm thickening that so you can see it a little better. And it is equal to 8. The larger number, now as soon as you say x is the larger number, you're defining that too, is 3 more than twice the second number. Well, twice the second number would be 2y, because we're saying if x is the larger, then this is the second number. The larger number is 3 more than twice the second number. So twice the second number plus 3. Now for number 4, Had to read this carefully. You have a motorboat that's traveling 22 miles per hour with the current and 8 miles an hour against the current. So you had to think about this one a little bit. So the boat itself has a speed that we don't know. We can call that the speed of the boat in still water. And then we have it going with the current, so we can use a C there. So the speed of the boat plus the speed of the current gets the boat to travel at 22 miles in all per hour. Now, this same boat in still water, its speed would be B, but now going against the current, it's going to only travel 8 kilometers or miles per hour here. So again, we're not solving these equations, we're just looking at how to set them up. But let's spend a moment before we raise it. Here, I think we'd use substitution. Here you could solve for x and use substitution. Here you could use substitution. You've solved for x, just put this value where the x is, and then solve it. Now this one, notice if we put a line underneath it, these will cancel out and we get 2b equals 30. So b equals 15. So that one was easy to do. Alright, let's raise it up a little. Now for this one, we have to designate what our letters are going to stand for. Let's say the new computer, we're going to call X. And the older model we'll call Y. And that's important in setting up what our letters refer to. So the new computer X, which is this, cost $100 more than twice the cost of the older model. So it's going to be twice the cost of the older model plus $100 more. Now the sum of the cost of the computers is $2,800. So there's the newer computer, the older computer, and this is $2,800. Number 6. The sum of two numbers is 77. So our two numbers are X and Y. So this is 77. Their difference, the difference of the two numbers, is 7. Find the two numbers. Well, again, notice if you just put a line under these cancel out. And here we would use substitution. Okay, let's look at number 7. The sum of two numbers, so X plus Y, is equal to twice their original difference. And I see I spotted a little error there, so this should be negative, their difference. Yeah, apologize for that. And the second part, if one number is 4 more than the other, we have this number is Y plus 4, 4 more than the other. Now that should be right. I don't know how I put a plus there. That should be a negative. You have to change that. Again, we're not solving it. We're just converting the English into equations. All right, number 8. The length of a rectangular garden is 5 meters more than twice the width. All right, now for something like this, often a picture is perhaps useful. The length of a garden is 5 meters more than twice the width. So this would be, remember, for perimeter, it's length and width. So we're saying the length, which is our L, is 5 more than twice the width. So twice the width plus 5 here. And then we have to know that the formula for perimeter is 2 lengths plus 2 widths equals the perimeter. And here we know that 2 lengths plus 2 widths then is equal to 70. So I think the way to solve this would be substitution, where you're going to put this where the L is if you were to solve it. And I think we can fit in number 9 here. This is similar to our boat up here. An airplane travels this many miles with the wind. So here's the rate of the plane in still air plus the speed of the wind. It's going to travel 245. And here we have the plane going against the wind. That is, the wind is kind of pushing you backwards. The rate of the plane in still air minus the speed of the wind is 175. Now for this one, again, you would just add them up because these are going to cancel out, and you get 2p equals the sum here. Now this last one on this page is someone's buying office supplies and buys 12 reams of paper and 8 boxes of writing tablets. So I'm using the P for paper and the T for tablets, and it costs this much money. He later buys 9 reams of paper and 10 boxes of tablets, and it costs this much. So there's our equation. Now this one would be a challenge, and I find that often there's one like this on your test. So how would you do it? Well, you have to modify this equation, and then later this equation, so one of these would cancel out. So if I multiplied, let's say, this first equation by a negative 10, this would become a negative 80t. And I multiply this equation by an 8, this term would become a positive 80t. So you would have a negative 80t and a positive 80t. These would cancel out. You'd have to do these other numbers, of course, and then do the work, but that would be the technique for solving that. Now I've seen one like this too in our text. So how many pounds of horse feed with 20% oats and horse feed with 5% oats should be mixed to yield 20 pounds of horse feed with 11% oats? Well, we know from this that the amount of, let's say, 20% that we're going to call X and 5% that we're going to call Y altogether is going to be 20. Now, we have 20% of the X amount and 5% of the Y amount is going to eventually become 11%. That's what we want to get a mixture of our 20. And there's the equations. And I'd probably use substitution for that. Another famous one is movie theaters or any kind of event where you're going to have, let's say, adults and children, and then you're going to sell tickets at different prices, and you're going to have a total receipt of this and this many tickets sold. So we can use the letter A for the adult, the number of adults, and the number of children attending, we say, is 460. And the adult tickets cost $7.50 for each adult ticket. This will give you the total amount for gate receipt for adult tickets. Children tickets, we said, were $4.50. And then all of the receipts totaled $2,604. So again, substitution solve for A or C. You could get rid of the decimals if you want. You'd have to add 2 places here if you did so. Whatever method. Okay. Number 13. 2 people on bicycles start at the same place and ride in opposite directions. So they're starting here, one going this way and the other going this way. And then eventually they're 48 or 84 miles apart. So, do we know the rate of the bicycle riders? And the answer is no. So we're going to call that R. That would be one of them that's going a little slower. The other one's going a little faster. So, we're not using 2 variables here, but we could have. We're just using one. So our equation will be the rate of one, which is rate times time. They're both going 3 hours, plus the rate of the other times the 3 hours. That's going to be 84. So there's a way to do it. All right, number 14. We have a triangle, that we've made a triangle here. And it says one angle is twice the second angle. So I'm using the letter S for the second angle. So if S is one angle, then another would be twice the second angle. So this would be 2S. And the third angle is 20 degrees less than the second angle. So there's the second angle, 20 degrees less. And this is the angles of all triangles add up to 180. So the second angle, another angle, and another angle. These are your 3 angles here. and we're just adding them all together. So this would be s minus 20. And again, the picture is not proportionate, but gives you a place to put your thing. So it's the sum of these equal 180. Continuing on, we've made a little diagram for the perimeter. Now remember, perimeter of a triangle is just the sum of the three sides. So that's what I've set it up. This was like your original side. Then one side is 4 centimeters longer, and then the other side is twice that plus 2. So the equation here would be s plus s plus 4 plus 2s plus 2 equals your total perimeter. All right, number 16. One number is 4 times the second number. Well, we had some like this. This is one number. It's going to be 4 times the second number. Twice the second number is 3 more than the first. Well, the first is x plus 3. So, not too bad here. All right, going on to the boat traveling. And we had one very much like this already. The speed of the boat plus the current goes 28.3. Now the speed of the boat against the current is 12.7. And again, nicely, these cancel out. You're going to get 2b equals this sum, and this cancels, makes a whole number, so it's rather easy to solve. Now, we don't have number 18. I already took this out because this involves 3 letters, and we didn't do those. Now, going on to the last 2, a new salesperson can receive a salary of this much plus 10% commission, or a weekly salary of this much plus a 15% commission. How many sales per week make both arrangements the same amount? So here we could think of y equals 10% of a certain amount plus 400, or y equals 15% of the certain amount plus 138. And in a sense, we have the equation y equals y, which will be this part equals this part where you solve for x, similar to the cost function that we did earlier in the revenue function. And the last one is a mixture problem where you're getting eventually 120 milliliters of something. So your 3% will be the x, and the 7% will be the y. So we know the amount of x plus the amount of y eventually will be 120. So 3% of the x plus 7% of the y is going to yield 5% of the 120. And we're going to keep this under 40 minutes. So again, we didn't solve this, you could imagine. Now on your test, there's only 10 questions on your test for Chapter 4. So you may get one or two problems. You want to be familiar with putting them into an equation and then being able to solve the equation, and that takes time, and thinking of it and then recalling your skill. Again, I strongly suggest you do the self-assessment to get a practice test, and then we have our test next lab.